To give a huge thank you to the professors and staff who so graciously ran this program. I'm really excited to be continuing my journey forward into the future. I had absolutely no experience in coding, very little to no experience in math and logic, and I'm really excited to continue in this. My project, which is called Ancient Coding, which I've written here on PyCharm, which is something I've grown to love, is about seeing how ancients might do math. We have, at this point, ancient Egyptians. We have the Russian peasant, as it's called, according to a website which I'll reference shortly, their system, and we have a modern computing perspective. So the idea is that we get to see the interrelationships between these three systems and the magic of mathematics. Before we get into it, though, I'd like to dedicate some of this project to this website, cutttheknot.org, and to Alexander Bogomolny, great mathematician, great math educator, passed away July 6, 2018. Good friends with Nassim interesting figure in our current times, really smart guy, has a lot of great ideas about math and risk management. I get a lot of ideas from, and a lot of people get a lot of ideas for coding and programming through this. I wrote my code on my own using for and while loops, and it was a struggle, but after I finished it, I've seen a lot of people who have learned to code through finding problems in here and then writing them in Python. So, quick explanation of my program. I'm going to try to keep it down to the 2 minutes, even though I'm a little bit over. Basically, what I do, I'm going to summon the program. So Python 3 ancient coding.py, and it asks you for an equation of your choosing. I'll try 8 times 9, and I'll start with Russian peasant. We'll see how they use their multiplication system to solve it, which apparently is a pretty old and very useful system, very useful way to see it. I entered Russian multiplication, so nothing is happening there. So let's do that correctly. So Russian peasant. And what happens is it prints out a list of data. And basically a lot of this is just iterating over, rechecking what I've been doing. The formula, which I'll show you here, which is in a column, is it takes a larger number, 9, and divides it by 2 while letting go of the remainder till the result is 1. It takes a smaller number, which in this case is 8, and multiplies it by 2 till the result of that list, the length of the list is the same as that of length 1. Next, it will find the uneven numbers in the first list, which in this case are located in indexes 0 and 3, which are 1 and 9, and directly across from those indexes, it will add those numbers together. So in this case, we'll add 8 to 64, because in this list, those relate to numbers 0, or indexes 0 and 3, and 8 plus 64 gives us the product of 72. Let's see how something like this might work in the Egyptian system. Let's see 5 times 17, and we will use the Egyptian system. And that gives us this result. And so it prints out lists beneath each number. What the ancient Egyptians would do, they would use multiples of powers of 2. And they would go up to powers of 2 until that power of 2 they went up to was less than the smaller number for a smaller number list. So it goes 1, 2, 4 for 5. And then the length of that list, that index, they would multiply the bigger number list by, which is 17. So it goes 17, 34, 68. Multiplying 2 times here, because we multiply 2 times here. The index for the first list, in this case for the Egyptian multiplication, would be 0 and 2. 1 plus 4 equals 5. For the smaller number, the Egyptian multiplication, we always want to find the numbers that when added together create the smaller number. In this case, 1 plus 4 equals 5. And as we run this index 0 and 2 over our bigger number multiplication list, that gives us 1768. 17 plus 68 is 85. At this point, I'm still building out the modern system. that's an equation that it wouldn't be able to detect. But the modern system, I'd like for people to kind of go about figuring it out on their own with the help and guidance of the computer. So modern computing, what happens is that the computer sees things as collections of zeros and ones, or sees numbers in particular as collections of zeros and ones. So this says the computer sees that. And to reach its sum, it marks as 1 the numbers that it's using to compute the numbers ultimately. And the numbers that they're used in the process but not actually creating the sum are marked with a 0. And this is very rudimentary, not the most clear explanation, but I think we can get some value from this. So going back to the Egyptian case here, the 1 would be a 1, the 4 would also be a 1, the 2 would be a 0 because it's not being used, 34 is also 0, it's not being used, 17 is a 1 or it's on circuit, 68 is a 1 or it's on circuit, and those added together creating our result. I hope to build in more interactive elements. I'm working on that. I'm also have a new computer coming. This computer seems to be burning out when I'm trying to run graphical interfaces on it, but it's a pretty old Mac, about a 10-year-old Mac, and it needs a battery change and some other things going on. So I'm hoping to make it a little bit more interactive. Got a screenshot which I pulled off of the Bogomani site where I'd like for columns to be interactive, which was working actually for me up until earlier this morning when the system seems to crash when I'm running tcanners. So just for safety purposes, I'm just showing a screenshot. But you'd run the program as the idea if I did 18 times 85 equaling 1530, 2 plus 16, and my multiples of 2 equal 18. Then I take the numbers directly across, 170 plus 1360 equals 1530. So thanks so much for checking out my project. Again, very basic compared to a lot of people's projects. It's been an absolute joy to work with everybody here. Thanks so much for being here and watching. Thanks to Alexander Bogomani. Thanks to Professors Chris and Professor Moran. And keep on checking out sites and feel free to connect, and I'll send links. And I hope everyone's having a great night. And to connect in the future on our coding journey. Bye-bye.